Welcome to section 11.2, areas of regular polygons. Today's objective is to find the area of an equilateral triangle and a regular polygon. To find the area of an equilateral triangle, we have to use the formula listed below. The area of an equilateral triangle is 1/4 the square of the length of the side times the square root of 3. So let's figure out where this formula comes from. So if I have the triangle, that's an equilateral triangle, and all the sides are the same. And if all the sides are same, I know that all the angles have to be 60. Now, if I were to chop this triangle in half, I'd be left with a right triangle that has a right angle here, a 60-degree angle here, and a 30-degree angle here. Now remember, our hypotenuse is still S. Our base would now be S divided by 2. And opposite of 60 would be the longest time times the square root of 3. So we have the square root of 3 times S divided by 2. Now we know the area equation is 1/2 the base times the height. So here we do 1/2 the base, which is this whole side S, times the height, which is the square root of 3 times S over 2. When we simplify that, we get 1/4 the square root of 3 times S squared. And that's where that formula comes from. So now let's find the area of an equilateral triangle with a 4-inch side. So we have our equation. Area equals 1/4 the square root of 3 times S squared. We know the sides are 4 inches. So 4 squared. So that equals 16 over 4 times the square root of 3. Which leaves us with 4 square roots of 3 inches squared. So if we have a polygon that's circumscribed in a circle, the center and radius of that polygon is the center and radius of the circle. So in this image here, we see this hexagon circumscribed in this circle. We know the center of it would be the center of the circle, and the radius would be whatever the radius of the circle is. This would be the radius of our polygon. Now we're going to be looking at polygons as a collection of triangles. So this new term here called apothem, we're going to define it as the distance from the center to the side of the polygon. So the distance of the center means from here to the center of the side. So here's the side. Here would be the center of it, right here. So this length, we call that the apothem, or we can refer to it as the height. When we're talking about the central angle of a regular polygon, we're talking about the angle whose vertex is the center and whose sides contain 2 consecutive vertices of the polygon. When we're talking about 2 consecutive vertices, here's one and here's one. So the angle AGB, that would be an example of a central angle. Now to find the measure of the central angle, if we want to find the measure of the central angle, we just take 360 degrees and divide it by how many sides there are. So here we have 1, 2, 3, 4, 5, 6. So to find the measure of this central angle right here, we divide 360 by 6, which gives us 60 degrees. Now to find the area of a regular polygon, we're going to use the equation written in this format. And we know the area of a regular n-gon with side length s is half the product of the apothem A and the perimeter P. So you can either use the equation A equals 1/2 the apothem times the perimeter, or A equals 1/2 the apothem times the number of sides. Okay, so let's find the area of the square. So to find the area of the square, we're going to use our equation. Area equals 1/2 the apothem times the perimeter. So we know that the apothem is the length of this right here. So that's 4. And we can figure out the perimeter by thinking, okay, if half of this is 4, then the whole thing has to be 8. So all my sides are 8. If that's the case, I know 8 times 4 is 32. And when I do this, I get 64 units squared. Another way to think of finding the area of a regular polygon is to think of it as finding the area of one triangle and multiplying that by the number of triangles. Now we can think of it this way because a regular polygon has a lot of triangles inside of it, and they're all the same. So if I find the area of one triangle and multiply that by how many triangles there are, I'll be able to find the area of the regular polygon. So let's find the area of one of these triangles to help us find the area of the regular polygon. So let's work with this triangle here at the bottom. So we know the radius is 4 centimeters. So this length is 4 and this length is 4. At this point, we have an equilateral triangle. So we use our equation for the equilateral triangle, which is area equals 1 quarter times the square root of 3 times the side squared. We know the sides are 4. 4 squared is 16. 16 divided by 4 times the square root of 3 equals 4 square roots of 3 centimeters squared. So that's the area of triangle 1. Now, like I said, I had 6 triangles here. So I take my value of 4 times the square root of 3 and just multiply that by 6. So the area of this regular hexagon is 24 times the square root of 3 centimeters squared. Now we found the area. Now the perimeter is just all the side lengths. So all of them are 4. It's a regular hexagon. So it's just 4 times 6, which gives me 24 centimeters. So to find the area of a regular pentagon is a little more difficult than finding the area of a regular hexagon. Now I want to go over this one in class, so I want everyone to copy this problem down along with the homework, and that'll be the end of this video. So here's the pentagon problem. Please copy this down. And here is your classwork for section 11.2.